Welcome to Classes with Atish. In today's lesson, we will start with functions. This will be the first in the series of videos in calculus. Make sure you review this lesson very closely because functions is a very integral part of calculus, and without the correct understanding of this subject, everything else in calculus will become very confusing. So make sure you pay good attention. Okay? With that, let's get started. Before I start to jump into details of what a function is and what are the different types of functions, properties of functions, let's make sure that we understand a few notations and few number systems because that will be widely used during this lesson. Let us first define some set of numbers and some notations that will be used during this lesson and in calculus in general. We denote the set of natural numbers by capital N, and natural numbers is the set of 1, 2, 3, goes on like this. Okay. We denote the set of whole numbers by W, and it's the set of 0, 1, 2, 3, goes like this. The set of real numbers is denoted by R. These are all possible numbers on the number line, includes all natural numbers, whole numbers, rational numbers, irrational numbers, everything. Okay. Set of integers as Z, and this is minus 3, all negative integers, 0, all positive integers, and such. Okay. The rational numbers are numbers that can be denoted in this fashion, P by Q, where P and Q belong to natural numbers. Okay. And Q is not equals to 0. Okay. So irrational numbers will be numbers that cannot be represented like this. So examples of irrational numbers would be square root of 2, pi, things like that. Okay. So these cannot be represented by P over Q. Okay. Real numbers is the set of all rational numbers plus all irrational numbers. Okay. Next thing is, what are closed and open intervals? Okay. Let's write that down first. So closed intervals are represented by square brackets a comma b. So what that means is these are set of all numbers that are greater than or equal to a and less than equal to b. Okay. Open interval is represented like this. Open this bracket a comma b. This represents x is greater than a but less than b. So it does not include a and b. Okay. Some ranges can be represented as like a combination. So it could be open bracket a comma close bracket b. So this would mean x is greater than a but less than equal to b. Similarly, you could have closed bracket a comma b open bracket. This means x is greater than equal to a but less than b. Okay. So that's the definition of open and closed intervals. The next important concept that I want to introduce at this point is the division by zero condition. Okay. Let's write it down. Okay. Division by zero must always be avoided. Why? I will not go into details about that, but anything divided by 0 is meaningless or undefined. Okay. It can lead to some inconsistent results. It can also not be defined. So division by 0 is to be avoided at all costs. What I mean by that is, let's say we have this condition, x divided by x is equals to 1. This condition is all good. This is where x belongs to the set of real numbers, except when x is not equals to 0. So we'll have to avoid this condition. Okay, x square minus a square divided by x minus a is equals to x plus a, where x belongs to the set of real numbers. Again, in this case, all x's can satisfy this except for when x is equals to a. Why? Because at x equals to a, this denominator becomes 0, and anything divided by 0 is undefined. So we must avoid it. Another example, 1 minus cos x by sin x is equals to tan x by 2. Okay. So again, here x belongs to real numbers except when sin x is equals to 0, that is x is equals to n pi, where n is the set of whole numbers. Okay, so always remember division by 0, this has to be avoided at all costs. In order to understand functions better, let's introduce a few concepts. Okay, you might already know about these, but first is ordered pairs. So ordered pairs are two numbers which are represented like this, a comma b, okay, where the order matters. A comma b and b comma a, they are not equal. Okay, there could be a set of ordered pairs which we represent like this. Let's say 1 comma 2 comma 2 comma 3 comma 4 comma 5, things like this. Okay, this is a set of ordered pairs. Let's also consider two sets. We'll call that set A and set B. Let's say in set A we have these numbers 1, 2 and 4. Okay, and then in set B we have these numbers 2, 3 and 5. Okay, now how many unique number of ordered pairs between set A and set B can happen? So number of elements in set A is 3, number of elements in set B is 3, total number of, so if we do a Cartesian product is defined as A Cartesian product B. In this, what happens is, for every element in A, it is ordered with every other element of B. So you will have 1 comma 2, 1 comma 3, 1 comma 5, okay, 2 comma 2, 2 comma 3, 2 comma 5 and 4 comma 2, 4 comma 3 and 4 comma 5. Okay, so this is what is called a Cartesian product. So it has all ordered pairs that can happen taking one element of A with each of the elements of B. Okay, so obviously number of elements in A cross or A Cartesian product B is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is number of elements in A times number of elements in B. Okay, now let's say we define a relation. We define a relation from A to B. Okay, how do we denote that? Relation are such that A to B, okay, we define a relation, we name that R, A to B, such that relation equals A comma B, so all ordered pairs satisfying A belonging to the set A, B belonging to set B, and the condition is A plus 1 equals B. Okay. So this is the relation that we have defined between A and B. So obviously if you see, this ordered pair is defined by this relation. Every element A, if we add 1 to that, we get the element B. Okay. Now let me define few other concepts as well. First is domain. So domain of a relation, it is denoted by dr. It is defined as all the elements in set A for which this relation is defined. Okay. So in this case, it would be 1, 2 and 4. Okay. Range, which is denoted by RR, is defined as all the elements of set B that is an output of the relation that exists between A and B. So in this case, we have 2, 3 and 5. Okay. Now what is codomain? Now in set B, we could have other numbers too, like let's say 7. But we do not have a corresponding number which satisfies this relation in one of the elements in set A. No worries, but codomain, so this is represented as CODR, is the entire set B. So 2, 3, 5 and 7. Okay. So that is what the relations are. So the concept of relation is important because this will lead you to the concept of functions. Okay. One other concept before I move on. So if set A has P number of elements, if set B has Q number of elements, right? Then we already looked at number of elements in Cartesian product of A and B is NA times NB, which is P times Q. Okay. Now, if there is a question, how many different unique relations can be established between A and B? The answer is, so number of relations that can exist between A and B is equal to 2 to the power P times Q. Okay. And we define one of those relations here. So we can define as many number of different relations as possible, but we are limited to 2 to the power P times Q. Now that we understand the concept of relations, what is a function? So a function is a special type of relation. It's a special type of relation which satisfies 3 criteria. Number 1, there can only be one mapping possible from A to B. Okay. Let's take an example. Let's say this is the set of A and this is the set of B. Okay. We have 1, -1, 2, 3. Okay. We have 1, 2, 4, 9 and maybe 10 in set of B. Okay. Now there is a function defined between A and B. Let's say it is function f. Okay. And how do we denote that? Function is such that it's from A to B. Small a belongs to the set of A. Small b belongs to the set of B. This we will call x, which is an independent variable. This we will call y, which is a dependent variable. Okay, and the function is defined on x such that it's x squared. Okay. Now only one mapping possible from A to B. So let's look at that. 1 squared is 1. Minus 1 squared is also 1. 2 squared is 4. And 3 squared is 9. Okay. When I say only one mapping possible from A to B, this one, if the input variable or the independent variable is input in this function, you can only get one result. It's possible that another independent variable can give you the same result, but one independent variable cannot give you multiple results. Okay, so that is what is meant by only one mapping possible from A to B. Okay, rule number 2. Every pre-image should have only one image. Okay, now these are also called pre-image and these are called image. Okay, so every pre-image should have only one image. And rule number 3, all pre-images should have an image. Okay, so here you can see there are few numbers like number 2, number 10. These are not have a corresponding pre-image in A, which is okay, but you cannot have any number here sitting idle. All elements in set A, so all pre-images should have an image. Okay, so it's like there cannot be an independent variable for which this function is not defined. Similar to relations, we define domain of a function as df. Okay, this is the set of all pre-images in element A. So 1, minus 1, 2 and 3. So this is the domains. These are all the numbers for which, or all the elements for which this function is defined. Okay, what's the range of a function? The range of a function is all the images that can be defined for all the pre-images in the domain. Okay, so range will be 1, 4 and 9. Okay, and what is the codomain of the function? It's actually set B. So everything that's in set. Typically codomain is not that important, but for every function their domain and range is very important. So domain is all the set of elements for which the function is defined for, and range is all the set of elements which the function evaluates to. Okay, one other thing, not all, it's important actually, let me write it down. Not all inputs can be accepted in a function. Okay, So for example, this undefined number which would not evaluate to anything else in the set of P, this cannot be an input to this function. So it's not accepted. Okay. I'll give you some more examples here. Let's say there is a function that is defined f of x as 1 by x. Now, this function, what would be the domain of this function? This domain of this function, df, will be set of all real numbers except when x is 0. Right? Because as soon as x is 0, 1 by 0 is undefined. So you see, not all inputs can be accepted in a function. It cannot accept this input in this function. Okay. Similarly, not all outputs are possible in a function. Let's take an example. Let's say another function is defined fx as sine of x. Now, domain of that function fx can actually take the set of all real numbers. But sine x, range of the function, it is only, sine x can only take values from -1 to 1. You see, I am using that closed interval notation. Okay. So obviously it cannot take any real number. It can only take all real numbers between -1 and 1, both included. Okay. Okay, let's take some example of functions and let's try to define their domains and ranges. Alright. So the first function I want to introduce to you is the modulus function. Okay. So fx is mod x, or the absolute value of x. So this can actually be defined as fx is x when x is greater than or equal to 0, and it is minus x when x is less than 0. Okay. Some properties of this modulus function: mod a plus b will always be less than or equal to mod a plus mod b. Mod of a multiplied by b will be equal to mod a times mod b. Okay. If x, a and l are three numbers such that mod of x minus a is less than l, then a minus l will be less than x will be less than a plus l, where x belongs to, open bracket, a minus l, a plus l. So this is the open interval. So for this function, what would be the domain of this function? So the domain of this function will be the set of real numbers. Okay, because it is defined for all real numbers. However, what would be the range of this function? It can only take positive values, right? And also 0. So the range of this function will be the set of whole numbers. Okay. Let's take another example. fx is root over 1 minus x square. Now, one thing to note here, square of any number cannot be negative, from which it follows, if we represent this as y equals root 1 minus x square, so y square equals 1 minus x square. So from which it follows that 1 minus x square must be greater than or equal to 0, okay, or x square must be less than or equal to 1, or we can say x must lie between -1 and +1. So the domain of this function, which is all the valid values of x that it can take, what is the set of numbers for which this function is defined for? So this will be the closed bracket -1 to 1. What would be the range of this function? What values can y take? Now if you observe closely, maximum value of y is when x equals 0, so it is 1, right? So maximum value is 1. But what's the minimum value when x equals -1 or 1? Then this evaluates to 0. So this is 0. So the range of this function is from 0 to 1. Okay. Okay, let's take a few more examples. Number 3, y equals x minus 1 by x minus 2. Okay. So obviously this is, okay, so what's the domain of this function? X belongs to the set of all real numbers minus the number 2, because at x equals to 2 it becomes division by 0, and like I mentioned, we must always avoid division by 0 because it's undefined. So this function is undefined at x equals to 2. Okay, let's see next example. Now there could be a function which is defined like this: y equals x square when x is less than 0. It's equals to x when x is greater than equals 0 but less than equal to 1, and it's 1 by x when x is greater than 1. Okay, and we say x belongs to the set of real numbers. So a function can also be defined like this. It need not be just one formula, it could be 3 different formulas for different ranges of x. Number 5, let's say this function factorial x. Now we know that factorial only applies for natural numbers, so x belongs to the set of natural numbers. Okay, we can also have another function defined like this: y equals 1 by q, where when x is a rational number represented by p by q in the lowest terms, and y is equals to 0 whenever x is irrational. Okay, so a function can also be defined like this. Okay, so just remember the y values are called range, x values are called domain. Okay, the third thing that we will talk about in the next lesson is graph of functions. Okay, so for any function, if we have clarity on these 3 things, the range, the domain and the graph, then we can say we really understand that function completely. So in our next lesson, we will go over different types of functions, starting with some algebraic functions, some exponential functions, logarithmic functions and trigonometric functions, and we will build upon this concept, and we will also focus on the domain, range and the graph of those functions. Okay, till we meet next time, goodbye.